So the next session is going to be completely remote and is going to be led by Dr. Jennie Pryce, who many know. If anyone does know Jennie, she's a tremendous leader and also someone who takes initiative. And in this session, she has managed to do that and to make my life a little bit better, because she's going to actually take control of the session because everyone is going to be working remotely. Jennie is well-renowned for genetics, genomics, the DairyBio program, and works as a research scientist for AgVic and a professor of animal genetics at La Trobe Uni. I think if anyone's been in this space over any period of time, if they haven't ran into Jennie, they've probably read some of her publications or been the benefit of the research work that she's undertaken and also led within the Australian research world. Jennie does come from dairy farm background in Shrewsbury. I think I've got Shrewsbury relatively right, and even had bred pedigree Holstein cattle. So I think that's one of the beauty of people that come through and have that relationship with our industry, as well as the passion for what they do. Jennie was also, I think, and this is another credit to her and the industry, was awarded an American Dairy Science Association award in animal breeding and genetics for amount of publications, and this is something that is really well renowned, and it was an important award. So I'm now going to hand over to Jennie and her team, and thank her very much for taking the lead for me.
Thank you so much, Graham, for the introduction. And it is quite unnerving to see yourself massive on the screen there. I can see what Heather meant earlier on. So before I bring onto the virtual stage my colleagues Phuong, Mekonnen and Irene, I'll give you a quick overview of DairyBio program, and then we'll change it up and have a virtual on the couch with change makers for the DairyBio program. So DairyBio and its sister program Dairy Feedbase are jointly funded by Dairy Australia, the State Government of Victoria and the Gardner Foundation. And they invest in dairy research to deliver transformational herd and forage for productivity gains for Australian dairy farmers. So it's always important for us as researchers to think of the end game and how this is going to be implemented in practice. So it was launched in 2016. And it's a large-scale investment in biosciences. And the economic modelling estimated that the impact of DairyBio will be about $1.75 billion over 20 years. And that's from the forage program, delivering roughly $800 per hectare per year, and the animal program, $350 per cow per year. So the major work is at AgriBio. So me and my team of scientists, when we're in the office, which we haven't been for close on 1 year, we're based in the AgriBio building. However, we are, I think, quite flexible and quite nimble in terms of our location. So it really hasn't changed our work in terms of it's pretty much business as usual for us, because we access the supercomputers that are located in the AgriBio building. So with number crunchers, we basically deal with the data that predominantly farmers collect. So it's this transition to a work from home situation has actually suited many of us very well. That's in contrast, I guess, to a lot of the field work that we have happening, and in particular for the feed-based program. So our field experiments happen predominantly in Hamilton and Ellenbank. So on the DairyBio project, there's 12 projects. We have 12 science leaders, and there are over 20 PhD students. And there's an ongoing investment to improve both the infrastructure and the capability. So those are really important in addition to developing the research. We need the next generation coming through, obviously. Now, what's really neat, I think, about the way that we do our research, and this is nothing new, it's the way that we partner up with industry to make sure that those research developments actually hit the ground. So I'm really sincerely very grateful to DataGene in terms of helping us with this route, and to always, I guess, embrace the new opportunities and the new innovations that we generate that ultimately have benefit to dairy farmers. So for just a bit of a taster, I guess, in terms of the three main pillars of DairyBio, we have one, which is to improve the reliability and robustness of genomic breeding values in crossbreds and red breeds. And you'll hear more about that tomorrow. We have breeding value maintenance, so that's working on the breeding values that we've had for a long time and to improve them, such as fertility, for example, or type, and breeding values for new traits. This is where your mastitis resistance comes in, gestation length, health traits, and so on. And the little graphic on the right side shows I suppose, a cartoon in terms of where the benefits will actually come from. So we've seen that ramp up in terms of genetic gain. We also estimate that there'll be benefits from having better DNA-based tools. So this is being able to, I suppose, identify more accurately the genomics that's going to influence our cows and management tools, and also lower health costs. So let's quickly whiz through the major deliverables from DairyBio. So it started in 2016. The first kid off the block was the heat tolerance breeding values. This was already supported by previous research, so the last tweaks were done as part of DairyBio. But we really hit the ground running, and Mekonnen, who will speak later, did a lot of work over the first year and a half to make sure that we had everything in place for the gestation length and calving ease work. We also put a lot of effort into multi-trait models to improve type breeding values, and obviously worked very closely with, in particular, the breed societies to make sure that this is something that fits the bill in terms of how they see it play out. And that's been a consistent narrative all through this process, is listening and responding and delivering our research together. 2018-19, the mastitis breeding value research was finalised, and Mary Abdelsaid led that and did her research as part of DairyBio before moving into DataGene. Improving herds, so Joe Newton very heavily involved in that work in terms of valuing herd improvement. Design of the next XT genotyping tool complete. Iona McLeod will talk more detail about those sorts of things that we're developing in the sequencing and genotyping space tomorrow. If we start to look at the last 2 years of DairyBio, you can see things are starting to get quite crowded. That we've got the breeding values released for mastitis resistance, gestation length, type, calving ease. All of those came in April 2020, I think. 2019. Because everything was blending into each other over the last 12 months. Key genetic variants were identified for major traits of economic importance. Phuong Ho, who will talk to you, looked on MIR prediction of fertility and came up with a major innovation that we can use for other traits as well. We'll talk about that in the Q&A. We have red breed and crossbred genomics research completed, and Irene will talk to you about some of the research that she's done in this space. Irene and Phuong have worked together on doing genomics for some of the metabolic profiles, and we talk a little bit about that. And the evaluation of the value that you can get from New Zealand and Australian reference population. And again, Mekonnen and Iona in particular were heavily involved in that. If we move over to the last 12 months, an updated BPI and HWI, including mastitis, ABV, crossbred and red genomics, prioritized variants implemented, an updated feed saved. We've got a framework for methane emissions breeding value. Still quite a bit of work to do there, but we've got a framework that looks really promising, and field testing of the MIR prediction of fertility. So a lot has happened. And we'll now take an opportunity to go in a little bit deeper. Now, of course, this is an on the couch session, which is quite virtual. In reality, we're all at our workstations scattered across Melbourne. So at this point, I'd like to bring into the virtual room my colleagues, Irene, Phuong, and Mekonnen. So hopefully this will all work seamlessly.
Oh, good.
Cool, as if by magic. That's fantastic. Welcome, team. So I'd like to start, I guess, by, rather than me introducing the team members, to ask you one by one to just talk a little bit about who you are and what you do. So we'll start with Phuong.
Thanks, Jenny, and hi everyone there. On those I can't see, but anyway, hi everyone. My name is Phuong Ho, and I'm a research scientist at Agriculture Victoria, and we're based in Bandura. So I've been with AgVic since August 2015, so nearly 6 years now. But before coming to Australia, I spent 5 years in Europe for my higher education, which include 2 years at Wageningen University in the Netherlands for my master, and then 3 years in France at INRA for my PhD, where I specialize in developing biological models for predicting cow performance. That is also my research focus at AgVic since I arrived here. So apart from works outside of office hours, I like to play badminton, tennis, and also riding bikes. Thank you.
Thanks. Mekonnen.
Hi, everybody. My name is Mekonnen Haile-Mariam, and I'm a research scientist based at Agriculture Research Victoria. I have been working with the development and improvement of genetic evaluation for dairy traits, and mainly traits like fertility, health, and other functional traits. I have been with the Australian dairy industry for over 20 years, and I completed my PhD in 1999 and came to Australia in 1999, and I have been working here in Australia and enjoying it. In my spare time, I do some walking and read all history and so on, of documentaries and so on. Thank you.
Thank you. And Irene.
Hello, so my name is Irene. I'm also a research scientist at Agriculture Victoria. I'm originally from the Netherlands, so that's where I did my bachelor and master's. And after that, I did my PhD jointly in France and Denmark. And then after that, I moved to Melbourne in 2016. And in my spare time, I like to do horse riding, rock climbing, and hiking.
Cool. Thanks so much, guys. So I think it would be great just to start with a brief explanation of your research for DairyBio. So Mekonnen, you've got the longest time in the game, so I'll hand it over to you first.
Okay, thank you, Jenny. Over the last 5 years, we have focused on development of new genetic evaluation for new traits, as well as improving the existing traits. The traits that we worked on are mainly, as I already indicated, associated with health, animal welfare, and environmental impact. As you saw in the slides that Jenny presented, we have worked or developed new genetic evaluation for gestation lengths, mastitis resistance, and a number of type traits. And we also developed, since these were developed, genetic evaluations have been implemented by DataGen, and the dairy industry has started already receiving the new ABVs for those new traits. We also have made improvements to some of the existing traits, particularly calving ease, feed saved, and type traits, where we showed that by the use of the data in different ways, in a better way, we can increase the reliability of the breeding values by lots, by considerable proportion. And most of the improvements that we have delivered has been delivered, and some we still are working on some of the traits, improve some of the traits. One trait that we are working on, which we think will be delivered very soon, is semen fertility value. The semen fertility value was developed about 20 years ago, and then it needed some revision and improvement. We have done that, and that will be delivered very soon by DataIG. Thank you.
Thanks, Mekonnen. Phuong, same question to you.
All right, thanks, Jenny. I guess within the current DairyBio, my research focus has been mainly on developing the management tools to help farmers better manage their dairy herd, particularly in terms of health and fertility traits. Of course, with the ultimate purpose is to have improved the profitability of the farm. So specifically, most of the model that we've developed focus on using or exploring the abilities of using on-farm data, which is available on-farm or through herd testing program, like milk production and milk composition, to develop the models. But also we also explore the abilities of recently emerging data such as MIR, which you have heard a little bit this morning from Heather, as well as the new source of data. Jeffrey just gave a very good summary about that. So some of the tools that the model that we've recently worked, like MIR fertility, and also we also did research on MIR predictions of indicator of metabolic disorder, like Heather mentioned, as well as other traits like energy balance, methane emissions, or lameness as well.
Thanks, Phuong. And Irene, same question to you.
Yes, I've been working on various aspects of genomic prediction, so on the use of sequence data, on multi-breed prediction, and then more recently on genomic prediction of novel traits, such as Phuong's MIR predicted traits.
So coming back to the MIR, and it's been mentioned by both Phuong and Irene, and it's been a bit of a buzzword at both Herd 19 and now at Herd 21. For those who don't know what it is, Phuong, can you describe it and the work that you've been doing, especially in predicting fertility in MIR?
Yeah, so I assume, and I guess most of you here in the audience have seen this morning and also previously heard of the terms MIR, which stand for mid-infrared spectroscopy. So this technology has been out there for some time and is routinely used for analyzing milk composition traits like fat, protein, and lactose percentages. So what actually happened in this analysis process is that the MIR machine will shine a beam of light through milk sample, and then it's because of the interaction between different molecules in milk and the light will be absorbed at different frequency. So the outcome of this process is just like a series of light absorbent, which can be considered simply as like a unique signature of that milk sample at that particular milking, which we know that they can be used to predict milk composition. But increasingly, research have shown they can also be used to predict other traits related to the physiological status of the cows, as I mentioned, metabolic disorder, energy balance, for example. And our works on fertility space is more or less based on a similar principle. So firstly, MIR, we know that it can be used to predict metabolic condition, which are associated with fertility. So that's why we hypothesize that we can make use of MIR to directly predict fertility. So that's the hypothesis. The general idea behind the model is that we would have a tool that allows us to predict the likelihood of conception of a cow if she's inseminated in early joining period. So why is that important? So if the farmer can know this information, for example, they can use sex semens or premium semens to inseminate for those cows that are predicted to be having high likelihood of conception. We can say like they are good fertility cows. whereas poor fertility cows can be inseminated with beef semen, for example. So that is very much what the hypothesis as well as the idea behind our works on the MIR fertility.
So from just coming back to that, can you tell us how well it works?
Yeah. All right. So in terms of the absolute number of the accuracy that we got, on average is around 75%. So this morning Heather mentioned, the golden number accuracy for most of the Archinotis model is around 90%. So, given we are not there yet. However, given the fact that, we don't have to touch the cows, as well as fertility is a complicated trait. I get that is a very good starting point. That's a very promising number. And also, it's good to mention that compared to our other similar model overseas, like in Ireland and the US, where they got 65%, we got 75%, which is significantly improved accuracy. So yeah, it's quite promising at the moment.
Thank you. So, Irene, Phuong's done a nice job in terms of the MIR prediction, and you're a genomic prediction expert. Can you describe how you link the two areas for us?
Yeah, so for genomic prediction, it's really important to have a large reference population, because in general, when you increase the size of the reference population, the accuracy of prediction increases, and then the response to selection increases too. But for a lot of the novel traits, the data set is quite small, for example, because the traits are difficult to record. So if you look at indicator traits of early lactation health, they require blood samples. And then if you look at fertility, we do have a large data set, but it's still smaller than the number of records we have for milk production. But then if these traits can be predicted using MIR data, they only need a milk sample. So they could potentially be available on all cows with a milk sample. And so what I'm doing is estimating the genetic correlations between the MIR predicted traits and the traditional measured traits. And then testing out if including the MIR traits in the reference population will help to increase the accuracy of prediction.
So I'd like to come back, I guess, a bit to research highlights. And I think I'm probably going to guess what Phuong's is, but I'll let you tell us yourself what's been a highlight of your career so far as well, especially in the DairyBio timeframe.
Yeah, so over the past few years within the DairyBio program, I guess, there are other research projects on other area as well. But I think I would say my biggest highlight is the development of the MIR predictions of fertility tools. There are two things I want to just mention here. Firstly, because I think the idea behind this model, if that's going to be applied, is quite significant. As I said, the model can be used to rank cows in terms of their fertility or likelihood of conception that farmer can use to make their mating decision. And however, the important points that make me feel interested in too is that compared to other model overseas, we obtain higher accuracy. It is not only really because of the data, but it is because the unique step that unique approach that we apply for training the model when we develop it. We only train the model only on what we call extreme data, which is the data that only come from cows that conceive to first AI, and the cows that never conceived within the breeding season and was inseminated only once. So by using only contrast or extreme data, we think that it can improve the signal passing to the model. So that's why it can improve the model prediction accuracy. So it's turned out it's worked quite well. So compared to other model where they train the model on of the data, the accuracy is much lower. So that's why I think it's very promising there.
So you talked about biological extremes, and of course they exist for other traits. Do you think that the same method can be applied to predict other traits of interest for us?
Yeah, I think, and it's not only in biology, but there are other fields like human psychology. Some of research have also applied the same approach. It's worked quite well. And biologically, we have been successful with fertility, and I think that should work for other traits. And I have within the DairyBio too. I have a quick look on other traits like methane emission and indicators of or metabolic health or serum biomarkers. They seem to work, but at the moment the data that we got is quite small. So I think we need more data before we can actually confirm if that's working or not. But I think that's based on what I've done, I think that should work. Yeah.
Cool. So it's really nice to talk about the highlights, I guess, for the team. And Irene, I was wondering if you could talk us through what has been your highlight so far on your DairyBio journey.
Yeah, so a highlight for me was the result that I got for MIR predicted urea, because the genetic correlation between the urea measured in the blood and MIR predicted urea was very close to 1. So we can actually consider them as the same trait for genomic prediction. And then also using MIR predicted urea did help to increase the prediction accuracy for urea. So it really shows the potential of MIR predicted traits for genomic prediction.
Yes, of course, we could have that on as many cows that we have MIR data. So basically everything that's been herd tested would have an MIR urea prediction, which is amazing.
Yeah.
So just thinking a bit more about the urea trait, this might be a new one for people in the room. It's not something we've talked about a lot. Can you explain why it's important and what impact you think it might have for farmers?
So some countries, for example, New Zealand, they're selecting for reduced urinary nitrogen for environmental reasons. But there's also a bit of a debate of the relationship between urea and fertility and whether it can be used as an indicator trait for fertility. So we need to be a bit careful how to select for it and do a bit more research how it correlates with other traits.
So you mentioned the New Zealand interest, and how is collaboration or international collaboration helping in this trait area?
So we actually have a collaboration with New Zealand on combining the urea data between New Zealand and Australia. And so we're currently working on how to best use this resource.
Cool. Look forward to those results. Well, I've seen some of them. It's good. Thanks. Let's continue with the theme of research highlights. And Mekonnen, it's probably difficult to identify one favourite, but let's see what's been a highlight for you over the last 5 years.
Yeah, the highlight of my research over the last 5 years would be, I think, that we were able to release the ABV for mastitis resistance and gestation lengths. And the mastitis ABV is a result of over 10 years of research from our group. And it's, as we know, mastitis is a costly and economic disease, which costs dairy farmers a lot of money. So having ABV to improve mastitis resistance is a very useful one. And the other important, I think, the highlight from the research over the last 5 years is the calving yeast ABV, the improvement that we made for calving yeast ABV. And the calving yeast ABV is the most difficult trait to work on, and also it's one of the most useful traits because it's has both economic as well as animal welfare benefits. And up to recently, because of the way the data is analyzed and so on, and then low heritability of the traits, we were not able to provide the dairy industry with genomic breeding value. But the revision of the recent revisions that we put in and the improvement we put in, including multi-trait analysis and using the data instead of a sire model, but in animal model, and using more of the data, we are able to deliver a highly reliable ABV for calving yeast, and also we are able to deliver genomic breeding value for calving yeast.
That's really quite a remarkable result, and it shows how much it's worthwhile looking into these traits that we already have breeding values on and ways that we can improve them. But I want to go and talk a little bit more about health breeding values, such as mastitis and lameness. And we've been successful with a mastitis resistance ABV, and lameness is still very much work in progress. Can you explain why?
Yeah. The development of ABV for lameness is difficult because we don't have a large amount of good quality data compared to mastitis ABV. Mastitis probably is more important to the dairy industry, so we get more data coming into through the system, but not in the case of lameness. And probably there is some level of under-reporting or incomplete recording, and as a result of that, the incidence level of lameness is quite low. And there are also, we couldn't find good indicator traits that are associated with lameness that we can use to improve lameness breeding values. And hopefully in the coming 5 years, with more data and better quality data, we'll be able to develop ABVs for lameness. And we will be, I think if we don't succeed in one go, and we'll try, we'll give it another go. And as the amount of data that farmers provide to the industry or to the data genius, the data comes increases and the quality of it increases, then we'll all be able to provide reliable ABVs.
Oh, thank you. Phuong, can we talk a bit about what impact you think your research will have when translated into a herd test environment?
Yeah, I think most of our research related to MIR are quite, closely related to herd testing as well, because they are actually available through herd testing program. But I guess the work that we are more close to have an impact on herd testing at the moment is the MIR prediction of fertility. So firstly, at the research scale, given the accuracy that we obtain, together with Dr. Joe Newton, our colleagues at AgVic, we've shown that the tool that we've developed is better than calving date in terms of classifying and picking up the good and poor fertility cows. And as I mentioned before, it can be used for mating decision. Secondly, like at a natural follow-up step, so after the research stage, we've been collaborating with Datagene, Dairy Australia, HICO, Tassert, and Dairy Express to conduct a model validation of field testing using the data from last calving spring. So what happened was that the data was sent to us through her test center, and then we ran the model. We merged that data with other data from Datagene. We ran the model, produced the report, and sent it back to our her test center to share with the farmers. So our farmers are now doing pretest at the moment, and hopefully the result will come back to us probably in May. So by then we'll sit down and evaluate firstly the model performance, as well as the feedback from the dairy farmers in terms of the usefulness of the information that we produce in the report. But I guess if the model is to be applied, is going to have a strong influence on the herd testing. I get into different aspects. The first one is, I guess, the number of participants, a farmer participating in herd test program. Secondly, and I think it's consistent with what Heather presented this morning about not only the frequencies of herd testing, but also the moment, the time frame where herd test is done. At the moment, most herd tests are done monthly, so it can be changed weekly. If we combine the MIR fertility with other tools, we can prove them to be beneficial. And secondly, most of herd tests is not done in early lactation. We know that it's a busy period, but if we actually can prove the information collected in early lactation is critical, it's very beneficial, I think that's the place where herd testing practice might be changed.
Thanks. I'm going to ask the same kind of question, but on the genetic side of things to Mekonnen. Can you give us an indication of the kind of impact the DairyBio genetics research is having?
Yeah, yes, of course. Our research in Australia and around the world has increased the rate of genetic gain for most economic traits. The research that we did over the last 5 years has improved the profitability, animal welfare, and reduced environmental impact, concentrated on those areas. Of course, as we know, research in genetics as well as selection on genetics is a slow process, but it's a cumulative process. So even if you are making a little progress, because that little progress is cumulative over time, the progress that you are making will be very important. And genetic improvements. So for example, if we take fertility, the Australian dairy industry has put a substantial amount of investment to improve fertility of dairy cows. And we have done over the years extensive research and revision of the genetic evaluation for fertility. And finally, in recent years, we have been able to deliver a relatively good, high reliability breeding value for the Australian dairy industry. And the dairy farmers are currently using the fertility breeding value. And if we look at the breeding value of the bulls that are used, nobody almost uses the bulls which are below average, which means that the industry is making genetic progress in fertility traits. And therefore, we hope with the new released health and other traits that are like feed-safe traits, also the farmers will be benefiting and improving the genetic profitability of their herds.
Thanks. And genomics has been somewhat of a game changer, I think, especially for the new traits, Mekonnen.
Yes. I think genomics have been, and also I think a point that we need to watch is that, to look is that the dairy industry has been one of the first industries to embrace genomic selection. And since the introduction of genomic selection about 10 years ago, genetic gain in most economic traits have doubled around the world compared to pre-genomic era. However, most of the significant benefits that we see is in the improvement of noble traits like feed saved. So and also possibly in the future, methane emission and so on. So the feed safe breeding value cannot be delivered if we didn't have the genomic breeding, genomic evaluation. So the genomic evaluation is the key or the basis for having the feed-safe ABV. So the genomic prediction has been really a very critical means to deliver improved genetic evaluation.
Thank you. So we've spent a bit of time talking about whole genome sequence data and trying to understand how genes work and how this can be useful for genomic prediction. Can you describe how this can translate into more reliable breeding values and give some examples of how it looks useful?
Yeah, so if you just increase the density and use all sequence information for genomic prediction, it doesn't necessarily increase the accuracy of prediction. But if we use that in sequence information to get closer to knowing where the genes are that, for example, influence milk production, we can use that information and include those genes directly, or variants that are very closely linked to them. So if we look at the standard SNP chips, they are using markers that are closely linked to those genes within breeds. But across breeds, those links are weaker. And so that's why genomic prediction works really well for breeds with a large reference population like Holstein. But for example, the Australian rats have a smaller population and that limits the accuracy. So it will be good for the smaller breeds if they can use the information from the Holsteins. But for that, we really need variants that are very close to the genes that have the effect we want to select for. And so sequence information can help to find those variants, and then we can include them on the SNP chips. And then that can help to increase the accuracy of genomic prediction, especially for prediction across breeds.
Cool. In the interests of time, we've got plenty more questions I think that we could ask, but I'll hand back to Graham and.
Thank you very much, Jenny. Wonderful, amazing in 40 minutes how we've managed to get so much on the background and the people that are generally not seen at forums and out there, but how valuable the work is. So congratulations. Unfortunately, time is going to be against us on the question side of aspects, which is a real shame, because I think not only is we've just heard describe some of the things that are currently happening, but also many aspects that are going to be into the future that are going to have a big impact and add tremendous value to what we're doing. So Jenny and team, thank you very much, and yeah, unfortunately look one day that we can actually have you in the room to engage in a much wider cross section. So all the best.
Look forward to it. Thank you.